Hi everyone and welcome. I'm Kavya, Director of Product Marketing at 𝐿SME and I'll be your host for this session at 𝐿SME Conference. Good to have you all with us today. Really appreciate you joining in. A quick ask before we begin: please post your takeaways on LinkedIn or X and tag us and our speaker of the day. And of course, use #TestMeConf #TestMeConf so that the rest of the community can follow the conversation. And if you have any questions, please feel free to post it in the Q&A box so that we can take it towards the end of it. Great. So let me just get started with the introduction of this very interesting session. So for most engineers, right, the day job has quietly changed shape. I think less time is being spent producing the first draft of the code. More time and rather more time goes into deciding whether the draft in front of you is right. And that's a different skill altogether. It's tiring differently, of course, and very few teams have redesigned anything around it. The review process, the definition of done, and the way people are evaluated. So the question on the table is, what does engineering look like when reviewing becomes the main event, and what needs to change to make that work? And today we have Sumit Shatwara, who works on Agentic engineering practice and has been watching this shift up close in real teams. And Sumit is a deployed engineer with Cognition, and one of those folks who is working at the real forefront of this problem statement that I just shared. So please join me in welcoming Sumit with on the topic agentic engineering from writing code to reviewing it. Sumit, over to you, please.
Perfect. Thanks a lot, Kavya. Really appreciate for the great introduction. Hey everyone, I just saw the list. Thanks a lot for joining. Really appreciate you spending time on this session, and I hope you get a meaningful outcome from this. So let me start with a story. So during my second week at Cognition, I was working with one of the largest GSI, and during the pilot, I watched a pull request getting merged, all of them green checks, clean diff, approved, and the engineer who approved it never wrote a single line of it. Neither did any other developer from that particular team. An AI agent picked up the ticket or the prompt, a very good planned prompt, and a planned change. An agent did all the stuff, the planning, writing the code, running the test, and finally opening a PR. And just developer just read it and ask one question and then click merge, and that review took around 11 minutes. And writing that change, I would assume they were saying that it might take some 1 day or couple of days for them, right? So that is all about engineering, agentic engineering, I would say. My name is Sumit. As Kavya mentioned, I am a forward deployed engineer at Cognition, which means my job is to walk into some of the largest GSIs and their strategic customers, which are the most regulated code bases in the world, and put the coding agents to work inside them, which are the banks, insurers, enterprises, where the bad merge can be a headline rather than just a rollback. And around 8 years back, I was writing the Python plugin line by line, one function at a time. And now I am enabling thousands of engineers automate them. And in between, I have worked with companies like Red Hat, Neo4j, Google Waze recently to transform businesses of Indian enterprise with complex, scalable, hybrid cloud architectures along with cybersecurity as well. And today is not a slideshow with a demo bolted towards the end, but I have deliberately kept the demos in between with an idea that a live proof in between with the live context will make more sense. And most of the claims which I'm going to make today, you will watch it happen on those live demos, including the one that should worry every tester in this room. I can see a lot of testers, so I'm very happy that I hope you get a meaningful outcome from this. Yeah, thanks a lot. So let's start. So before any claims, one map, because AI codings gets used in multiple facets, and it can be used in five very different things, and differences decide everything else in this talk. So read the ladder to the left and to the right. So L0 is all of us before 2020, which is the human memory, human hands. It is like walking towards a journey. And L1 is all about completion, like or accelerating the development life cycle, like upgrading from walking to a riding a bicycle. And L2 is all about ID, which opens a file context, a human prompt as the trigger, one turn at a time. And most teams I meet today live at L2, and and they believe that they have seen what AI can do at the best with all the frontier models out there, right? And they think that they are the driver of a sports car. But the important line in this slide is the vertical in the middle, which is everything left of it is augmenting an individual, and everything on right is like multiplying a team. And that line is not crossed by a bigger model, but it is crossed by a different paradigm altogether, right? And then you can see the L3, where the context becomes the whole code base managed, and the trigger becomes a delegated task. We are going to talk about a lot in this session. So essentially, these are the agents which has its own machine, so it can iterate against the real feedback. It can run the test, it can read the failure, fix, and run again. And developers are not a driver anymore; they are the reviewer of the destination. So at level four, leaves the human trigger entirely, which essentially schedules and events uh, at the start of the work, where no human needs to come in between to switch the context and become the bottleneck, where agent can do all the automated stuff. And L5 is like a true AI software engineer, which can pull the work independently from the enterprise backlog, prioritize based on the business context, and iteratively correct its own mistakes until it reaches the goal, right? So hold this thought. Every rung up this ladder removes a human checkpoint, which really raises the value of the checkpoints that remain. And that is the verification, that is the review, and that is you all, which you are in the room. So, what actually changed between those two halves of that ladder? Essentially, it is the unit of software work, right? So, for 70 years, the unit was the same, a human at a keyboard producing the next line, next character, turn by turn. And every tool the industry has made, like the bestest of IDs of the world or linters of the world, made that keystroke faster and faster, which is, and talking about that is left card, the assistant era. The AI in this era, the AI suggests the fragments, and you as a engineer just execute. Useful, but notice who still owns the work. It's you. Essentially, you are doing the stitching, you are testing it, you are documenting it, and you are shipping it. And on the right card, the agent does not accept a keystroke, but rather it accepts a ticket. And it does not return a suggestion, but it returns a reviewable package, a plan, a traceable change, test, docs, and then finally a pull request, which is ready for your governance process like any other change. That word reviewable does all the work in this session or the talk, right? So when the unit of the work becomes the ticket, typing speed stops mattering, and three things become scarce: clarity of intent, architectural judgment, and finally the high quality review. And many of you in this room has been training for that world in your most of your career, right? Because I know, because I, in the first 2 years of my journey, I was also a QA engineer. And yes, I am talking about you all who are the QA engineer or testers, who can see that how your role becomes very important towards this new paradigm. So how should you hold these agents in your head? So there are essentially two mental models, and most of the engineers gets confused because these concepts get burned down if they don't understand it well, right? So the local agents, right, on the left side, which is if you're working on it, it is your editor, your file system, your attention, and synchronous by design, where you steer every step and you verify every step, and it makes you faster and faster, right? And based on the research, right, essentially by Microsoft and other orgs, like generation of the code is just like improves the 20% of the productivity, but 80% is still the lot of the manual stuff along the software lifecycle. So on the other hand, when we talk about the cloud agent is not a just another developer tool, but it is a team member with its own machine, where it clones the repo, it implements the code, runs the test, iterates over the failures, and opens the PR while you do something else, just like having a sip of coffee or running meetings or maybe sleeping, right? So which is asynchronous by design, which is why you can just delegate a fleet of them in parallel. So here is the economic asymmetry that makes this work. Reviewing takes minutes, but writing takes hours or days. Convert hours of writing into minutes of reviewing at a constant quality, and you have found a real leverage. But notice the one most important skill and process here, which is the constant quality, and that is not free. And the rest of the session is about what keeps it true and what happens when it is not. So, this is the sentence I say on day one, or probably all of my colleagues in our company when the enterprise rollout. And the one engineers resist the most, that you are not the driver anymore, you are the reviewer. The loop is easy to say, but it is hard to live, which is defining the task, delegate it to the cloud agents, review the output, and feedback on the PR, where the record lives, not in the chat window. The step people fail at it is delegation itself, which is letting it go. So typically, what we have seen is like engineers like to micromanage the agent, like a nervous parents, like watching their kids learning to drive the car which might crash, and then rechecking every intermediate step and destroy the entire advantage which they could get, right? So the skill is writing a task definition clear enough that you can afford to let go that probably which can take 12 hours, then reviewing the outcome with full attention that just takes 30 minutes. If you can just save that 12 hours, you have a massive leverage. I would like to say this statement, which is like drivers watch the road every second and reviewers just inspect the final destination. Different skill, but testers, you already have it and you know that very well. So, if you want to just remember one slide from this session, make it this one, right? Every delegation decision we make in the field goes through that one golden question as like, can success be verified without human judgment? That is the ultimate filter. Every single piece of work must be passed through that question before it touches to the cloud agent. Because if you think, right, okay, now I know that my role is changing and I need to delegate, but how should I delegate, right? So this is the golden question which you need to answer. And if the answer is yes, then if there is a mathematically objective way for agents to know that it has finished the job successfully, like if there is a comprehensive test suite or an API contract that every endpoint must conform to, a automated visual end-to-end regression testing framework, then probably it is a very strong agent candidate, because an agent can write the code, run the verifiers, see that it fails, writes the code again, run the verifiers again, and continue to do so indefinitely until it succeeds without ever needing a human to tell it whether it is right or wrong. But if the answer is no for this question, then the only way to know is if it is right is your judgment, which is your test, your memory, your architectural skills, or your experience from the past, which is an horrific incident from 2019, which is there in your mind and never documented anywhere, right? And it stays with you. Or better, you might need to refine the spec in a way until the parts of it becomes verifiable before it gets to the agent. But if you are, what this question takes you in the gray zone, which is the most real engineering work, then you need to stage it. There, the agent can help you research. You can decide the output of the research. Then agent implements your decided thing, and then finally you can review it. So notice what this question is really all about, right? Essentially, it is a testing question. The delegation boundary of your organization is exactly the coverage boundary of your verification. And often teams keep asking us that which is the best frontier model to buy so that we can improve our software engineering lifecycle. And I believe it is a wrong question. The ceiling on how much work you can safely delegate is not the model, but it is your test suite, which means that the people who can build the verification is the set speed limit for the entire AI adoption curve. And if the enterprise doesn't have an objective verification, then they cannot safely deploy the autonomous agents. And I believe personally, right, in the previous decades, QA engineers has been treated as a second-class citizen, sadly, into the software development lifecycle. But in this new agentic engineering world, uh, I believe QA has a much larger role to play. The more organizations can do the verification objectively, the better they can improve their adoption curve. That takes me to the first demo. Is like in this demo, what I'll do, how to delegate it in a better way, right? Hope you can see the screen. It's like imagine that you have got a very good well-defined task in the Jira, and you understand the task very well on this, and you're working on this particular GitHub repo, and the ticket task says that article slugs must be the URL safe, and essentially this application is all about a hypothetical social blogging portal. So whatever capabilities it has is similar to what you have been using in portals like Meta or similar ones. So here, this is how you delegate the task. It gives the full context on how to make this article slugs as an URL safe. It gives the requirements end to end, explains that how to implement this feature, and then it defines the success criteria, which is definition of the done, how it should raise the PR and what it should do, right? That's it. You just fire it, and then you can just close your laptop and you can do whatever you want to do, right? Which is the most important stuff to make the highest impact in for the organization. And then after a few minutes, it is gonna run. Since it will take some 3-4 minutes in the interest of time, let me show you the same session which has been already run, how it looks like. You can see I have written the same prompt which was pre-run here, and you can see that this particular agent, which is Devin, I can use this term interchangeably, like Devin. When I say Devin, it is cloud agent. When I say cloud agent, it is Devin in the context of our organization, which is Cognition, right? So here, what Devin is doing is like it's getting the full context from the repo. It in the backend, it has a full graph, the full documentation, how it looks like, and then it starts this session in a very isolated VM with full security, which is a clean VM with list privilege. So any enterprise org would be able to find run it as compared to the local developer machine. And it will create the full planning that how it thinks about approaching this problem and start implementing the code, right? You can see it has edited a couple of files. Then when it makes the change, it starts the Gradle to start the build. Then it actually does end-to-end job to build the binary, and then push the actual change to the branch, right? And it says the PR is up and running, and it says there are 10 article tests pass, as well as the spotless check is green locally as well. And then it also done an end-to-end testing of that. Basically, it has a visual regression automated test suite in the backend, which makes sure that how a agent can also not only run only the unit test or the integration test, but also manually by compiling the binary. It has its own machine, it has its own browser and ID, right? Just as an engineer, it deploys the application and tests the application end to end, right? So that's where it also records it. So before a senior developer sees and reviews this, it has a full reviewable package, the PR as well as the details of the PR, that how it has implemented all the test cases. If it needed to write the new test case, it writes the new test case as well. And then finally, with all the recording and screenshot that it has implemented that particular feature, which had a clear goal, and it submits the recording. And developer's job is just to go to this PR, which you can see here. All the diffs would be seen here. Either they can review directly from here, or they can just go to the PR here and start review the PR, including all the diffs which it has made, right? So this was the first demo. Moving back to the slide. So here you saw that verification closed the end-to-end loop, and I was only the one who just typed the ticket, nothing else I did, right? Now let me take you out of the trigger entirely. This is a new form factor altogether. So once you trust the whole agentic engineering loop, you can do something braver. Which I mean is, like, you can remove yourself from the start itself, or from the beginning of it. So essentially, we see three patterns we deploy in the field, and none of which begin with a human typing a prompt. First is remediating a vulnerabilities, where a scanner or a CI job flags a security finding, and Devin as an agent validates it, writes the patch, opens a fixed PR, and the security backlog, nobody ever starts draining on its own. And second, investigating bugs and CI failures, which can be an error, alert, or a failing test, fires. And then it triggers the Devin session. Devin tried to triages it, reproduce it in the isolated VM, as we saw previously, root causes it, proposes a fix, and then you developer's job is just need to make sure that they just need to review the PR. Essentially, what we have seen, right? If it just sends the alert and developer sees the alert and does the triaging and then fire the human trigger, it takes essentially 15 to 20 minutes. We are just removing that 15 to 20 minutes, essentially, where Devin does it automatically end to end, right? And last is monitoring a stream, where a relevant activity can appear in Slack or similar channels, right? Where Devin replies in thread with the context and turns the report into a scope ticket. And all three share the same shape, which is the event triggers, agent investigates, and finally the human approves. And essentially, we are moving the human from the trigger to the final physical gate. We never remove the human entirely, if you see in this particular form factor. And QA already knows this discipline as, like, automation without a gate is a blunder, but automation with a gate is a capacity, right? And the second pattern is not a diagram. Let me show you the actual demo, how it looks like. So imagine that midnight 3 a.m., right? You are a developer, an SRE engineer, or a tester for a bank, right? And this bank is very critical, and there is a internet banking application which typically does the simple transaction from an account to account, right? And then you see a defect coming on, right? You can see there is a defect. A simple capability is not working, which is pretty much common whenever a lot of change is happening or AI is writing the code. This type of errors can happen. And Devin, as I said, it immediately in the back end, right? It integrates with something like Sentry. As an alert, Sentry throws the notification to the Slack, and as soon as it notifies everyone, Devin already starts the session. You can see that Devin is investigating this issue. If I click on this, it moves to this particular session. You can see here that Devin has triggered this session just now, a few seconds ago. It has started the working, and it will take some few minutes to do end-to-end job. And I have already pre-run this session in the interest of time. Let me show you what Devin does. So here you can see, okay, this one. Let me show you this particular one. Yeah. So here you can see what Devin has done. Essentially, Devin has hypothetically considered the whole code base. It understood the type error via the Sentry, and as well as it also is talking to the Datadog via multiple channels, including MCP. And then it started the full investigation that what this error is all about. It has understood that which functions are getting impacted and what are the dependency mappings, right? In this, as if it is a, because it is a critical bug essentially, and bank is losing thousands of dollars every second or every minute. So your leadership team has asked you to start a panic button and make sure that you fix it as soon as possible. And you might see one error, right, and start fixing towards that and raise a pull request, right? But essentially, to do a full triaging, you need to understand the detailed code base, understand the root cause where it is coming from, the Sentry and Datadog, which Devin is actually doing that to understand the root cause and does the triaging or investigation of the bug end to end. And then understanding the whole dependency mapping, all the function, including understanding the database or the loggers, that how many times it has failed. It says that there is an evidence that it has happened 600 times in this particular time period, and I can confirm that this particular API is also returning error with 500 HTTP requests from the Datadog, right? And it impacts that every transfer attempt on this particular banking API fails with this error, right? And immediately it proposes the fix. It writes the fix, raises the PR, runs all the tests, and probably if whatever test suite is meeting, it also writes the test, and then it records on all the stuff, right? You can see that just like previously, whatever error is coming, it based on the PR branch, it has compiled the binary, run it on its own machine, and then it is actually doing the testing just like a typical Selenium or Playwright test would do, right? And then what you get as a part of it, right? Everything end to end. If you see how much time Devin has taken, 1 plus 5 plus 2 and then 3, just 8 minutes, 8 or 9 minutes. Imagine that if you don't have a cloud agent or something like that, something like this, right? Whenever the developer or Q engineer wakes up midnight on a panic mode, the best case, even with the best local agents or the IDs of the world, right? Uh, they can take 30 minutes or worst case, a couple of hours, or I don't know how many hours. And Devin is doing end-to-end stuff within just 9 minutes. And when the developer wakes up in the morning, they just see the end-to-end reviewable package, all the test case pass, CI going green, and then finally the run. And then their job becomes very, very easier, so that they can just, rather than panicking, they can reliably push the PR into the main branch by manually reviewing and checking it once. and reducing the SLAs or reducing the business loss as soon as possible efficiently. That was the second demo. So Act 2 was a real production alert, which we just discussed with a reviewed pull request, with nobody prompted anything about. Now, let me transition to a new paradigm, which is how that scale can shape up, right? What happens when the job is too big for a single agent? So some task, as I said, may be very, very big for one agent. So here the lead agent spins up more agents. They all work in parallel, and the lead aggregates and cleans the results back up. Orchestrators, there are agents and workers. We call it the whole hierarchy as a agent swarms in our language. And it is how we have built our security swarm as a product, which crawls the whole code base, even though it is multi-millions of lines of code, doesn't matter. Or even how large migrations run, or how a 1,000 repo or code quality audits finishes in days instead of quarters, right? So here the lead agent or the lead Devin decomposes the problem first, and exactly how a human orchestrator would do at the first place, like the decomposing the problem, parallelizing into the multiple scope task, and then aggregate all the results. Similarly, the same hierarchy is, if you see the shape of this diagram, though, it is the same management hierarchy, and the skills on which it is runs are the same: decomposition of the work, delegation, and finally the review. We did not automate the engineering judgment anyway or take it away from the human. We just maximize it so that whatever human thought that is impossible to do, which might take quarters or years, now we can finish those job in days, right? And humans still sit above the lead agent as a final gate, which is we make sure that we are not entirely removing the human, even though it can fire tens or hundreds of parallel sessions altogether. So this one is worth, I think, couple of minutes of your attention, because the numbers are hard to believe until you see the real fan out on the screens. So let's see the demo, the next part of this demo immediately, that how it looks like in our product, which is the Devin security swarm. So here you can see that on a particular code repo, we have a Devin has started a lead agent on the whole code base. This is the lead agent session you can see. And it starts the first agent, which is based on the threat model. It does the whole, how to do the scanning in terms of understanding the multiple security flows, which is an agentic application security offering from us. You can see that it has fired based on the batches of the code. Each batch minimum by default is 5 lines, so 5 files from the code, and it has around 30 odd files. So it has started 6 different Devin sessions to investigate the multiple parts of the code. And then there is one more agent, which is an aggregate agent, that whatever agent has found the security flows or vulnerabilities on an isolated fashion, then an aggregate agent comes into the picture to make sure that it deduplicates the error. It tries to understand that which are the false positives or which doesn't make sense, and create a complex attack chains. And finally, it because each session, because whatever true positives it finds, it starts a new sub-agent to validate this finding, to make sure that there are no false positives. And in the end, the team gets a single comprehensive list of a backlog of security, that which are the critical errors, which are the high, mediums, and lows, and which of them are the noise, which are the duplicate or false positives, because Devin couldn't reproduce on its machine, or it couldn't validate as an attacker, right? Because Devin is doing end-to-end stuff as an engineer rather than human doing the adversarial stuff here. And then once they know these are the critical bugs, they can just assign it to the Devin, and Devin will just go ahead and start a new session and start fix the bug, as just like you have seen the other session where Devin was fixing the bug, fixing the errors uh, or or running the task end to end, right? And then we are similarly working on a lot of other problem areas like migrations or checking the code qualities and tons of the other stuff, which is very difficult problem to solve. And we are, since we are building the future of software engineering, we are making sure that how we can have this new paradigm, which where we can help our customers taking their backlog from quarters to days. So this is the one slide of the map. You have seen some of those in the previous demos. So just notice it follows the end-to-end software development lifecycle, which we already run, or which you already run day in day out. So first, DeepWiki is to understand the code base fast and turns into a contextual documentation. Then there is a Ask David, which turns the requirements into the scope work. And then there is a Devin Cloud for the delegation, which we just saw. Desktop and CLI are just the local agent surface. We just talked about the difference between the local agents and the cloud agents as well. So we also have all the surface areas which our customers can use or you can use. And then Devin Review, which is about to matter in the next demo, which I'm going to show. You just saw the security swarm and the cloud agents doing the real quality engineering work. And finally, the automations, which you saw in the second demo, the banking one, which we just. The takeaway is just not the names here. It is that every SDLC stage now has an agentic surface, and all of them just share the one thing: human approving the gate. And finally, and the whole platform makes delivery a closed loop quality system, right? Where the agent grounds itself in a DeepWiki, as we saw previously, the knowledge or the project nodes. It does the planning. It does once it generates the right approach or the scope task, it can execute onto the isolated VMs or including Linux or Windows machine. And soon the macOS is coming soon in next couple of months. And then it runs the verifier. Then after running the test, if it fails, Devin executes again. And runs the verifiers again. It fails again. It runs it until it gets the pass, and then it delivers the PR. And then this is my favorite thing, which is it watches the CI as well, it reads the CI logs and reruns. If there is a failure in the CI gates, right, it reruns until it takes the pass. And then finally, the review with the video evidence and the test report attached, plus Devin review over the diff. So count the verification status, verify, CI, reviewer, three before. There are three different stages where a human actually reviews the PR, right? Which raises a question every tester in this room is already asking, right? What if all the three pass and code is still wrong? If we just keep the Devin review aside, let me show you exactly that particular scenario. So imagine that a developer got a call from the project manager or the architect at 5:55 p.m. in the evening that they need to finish the job before leaving off the desk or leaving off the office. And they just want to finish the job, right? And in that way, they don't scope the task properly, or they don't define the success criteria, as we saw earlier in the prompt. They will say, we keep getting this encoding bugs from the non-ASCII slugs in the URLs. Strip anything weird out of them. Some of the old slug tests are probably outdated, so fix whatever fails. Don't overthink. Just get the CI green and open a PR. It is just developer is so hurry. It just says, just fix some test fails, right? You just fix the test, just make the CI green anyhow, and then open the PR, right? And then Devin, while planning the test, it clearly highlights that user explicitly instructing the agent to fix the failing test, which overrides the general principle of treating the test as a source of truth. And I know that you as a quality engineer really don't like that if somebody tests your single source of truth, which any change needs to bound to, right? So it is just prioritizing the guidance, because the developer just wanted to do that, and it will just raise the PR. And once it raised the PR, you can see here it raises the PR, and that's where the Devin review comes in the picture. It can contribute to the meaningful output, that because the prompt was so bad and test cases were deleted, so it couldn't check the or it couldn't CI gate couldn't check the real issues in this stuff, right? And then there is a different AI agent, which is the Devin review agent, right? Imagine that the job, your job, right, or your is going from writing the code to reviewing the code, and you might get tons of the PR in this new paradigm. And developers are going to make this mistake in the hurry, and Devin review will run automatically on this PR, which is human generated or the Devin generated or any other coding tool, and it will just show all the bugs. You can see there are 3 bugs in this PR, which where Devin review has understand what is the git diffs here, what changes have been made, and there are some flags. Let me click on one of the errors. It says that articles with fully known Latin titles, if which didn't cover the global case, like if the titles are in some Spanish language or Chinese language, it will just fail there, right? And it will just get the blank address, and uh, Devin catches it before it opens the PR. So it catches it, it automatically fixes it, it says it's resolved, and the final PR which developer sees previously, right? It goes through a constant cycle, that whatever feedback Devin provided, it has fixed it. It has also run the test end to end, considering all the edge cases like Chinese language as well. It has passed all the cases, rewritten the test cases, and then finally, what comes to the senior developer is just a clean package, right? And that's how it makes the whole delivery as a closed loop quality system. Now I just wanted to quickly move. So what these are the typical use case which we see from our customers. It is not the greenfield use case, but these are essentially modernizing the stuff, technical, removing the technical debt, test case generation, or improving the test coverage, or removing the vulnerability backlog, right? And if I wanted to give you only one task, I would say just delegate the one verifiable task where you see you have an end-to-end test suite. It can be bug with the repro steps, or a dependency bug, or a test coverage gap. You just delegate the task, and then if you think it works, then just you can delegate the second one. And with that, I just wanted to close it here, that the job is not just to disappear here, it is inverting. Humans set the intent and approve the outcomes, and agents will do the mechanical execution in the middle. Thank you, and I am just happy to answer any questions.
Thank you so much, Sumit. Really appreciate this. We have a couple of minutes, so I'll just bring the questions up on the screen. Um, Give me 1 second, please. So the first question is, how long, on an average, does it take Devin to complete the SDLC process?
Um, if you see from planning to the reviewable PR, most of the time is to define the success criteria for the delegation internally. If you know that, if you can answer that golden question which I talked about, that can success be verified without human judgment? If the answer is true, and you know that how to create a very good prompt, even if you don't know how to create the prompt, we have a mechanism where you can just define the task in a clear goals,
Mhm.
and then Devin can help you create the prompt and to start the task, right? So in that way, if you have everything connected, right, if you have right CI pipeline in place, or whatever gates you have placed across the own end-to-end life cycle, Devin can do the whole SDLC process within a span of 10 to 30 minutes, depends on the type of job, how complex it is. If it covers the whole code base, right, which we see in the security swarm, it might take
Yeah.
a few days, because it is doing the quarterly job, and maximizing the potential of having the efficiency game of 100x. But with a typical task which developer does in 3 to 6 hours, Devin can do in 30 minutes end to end. Yeah.
Great. I'll take one last question, which is mobile gaming a good test or use case for Devin? If so, why?
Absolutely. So I just mentioned some VMs, but I also mentioned something like macOS is coming soon, where you can run the Xcode Developer Toolkit, where it has iOS simulation, or we also have Android emulators supported as well on these machines. So if you have a mobile app, whether it is gaming or anything else, doesn't matter. Devin can do the job for you.
Sounds great. Thank you so much, Sumit. That brings us to the end of the session. I really appreciate you giving us the time today, and thank you so much to our audience for joining in. If you resonated with the session and were able to take some takeaways, please make sure that you're sharing it, with your peers on social media or with each other. Once again, Sumit, really appreciate it. Thank you so much. And to the audience, we have more sessions lined up for you. So yeah, please move on to the next session, please. Thank you, Sumit. Have a great day. Thank you, everyone.
Thanks a lot, everyone.